Good morning, students. All. Last class, wave optics part 1 is completed. We'll do the remaining problems in the wave optics. See, in a diffraction pattern by a wire, on increasing the diameter of wire, fringe width, what will happen? They are asking. So, in a diffraction of the wire, fringe width in single slit diffraction, formula for the fringe width. Formula for the fringe width will be beta is equal to lambda t by a. What is d here? Distance between wire and screen. What is a here? Diameter of the wire. So fringe width and diameter of the wire both will be inversely proportionate. When diameter increases, fringe width will decrease. So this is the answer for it. Okay. Next, see the next question. In a single slit diffraction experiment, first minimum for red light coincide with the first maximum of some other wavelength lambda. Okay. So for minimum, what is the condition? D sin theta is equal to n lambda in a diffraction for maximum. D sin theta is equal to 2n plus 1 into lambda by 2. They gave these two are equal. Okay. Sling is, so what will happen here? It will be first minimum means n value will be 1 here, this one. Lambda value will be 660 nanometer, means 6,600 angstrom unit. And for this also first maximum divided by 2 into lambda. So lambda is equal to 2 by 3 into 6,600. So lambda value will be 4,400 angstrom unit. First minimum coincides with one wavelength, coincides with first maximum with another wavelength. What is that wavelength? They are asking. So this is the answer for it. See the next question. Smallest angular separation resolved by the human eye given aperture is 2.5 mm. So A value will be 2.5 into 10 power minus 3. Lambda value will be, so this value 5,500 into 10 power minus 10 means 5.5 into 10 power minus 7 meter. Okay, 1 millimeter marking I can view. So, what is the largest distance that it can view? That is the question. So, delta theta is equal to 1.2 lambda by A. So, 1.22 lambda value 5.5 into 10 power minus 7 A value 2.5 into 10 power minus 3. If we calculate this value, this will be 2.7 into power minus 4 radians will come. But this delta theta is equal to, here I is there. This distance is how much they are asking. Capital D value is how much they are asking. This they gave it as 1 mm. This value will be delta theta. So if it is a small d, so delta theta is equal to small d by capital D. 2.7 into 10 power minus 4. Capital D is equal to small d 1 mm means 1 into 10 power minus 3 by 2.7 into 10 power minus 4. This value 10 by 2.7. If we calculate this value, approximately 3.7 meter. So answer for this will be this one, 3.7 meter. Next, assuming the light of wavelength 6000 angstrom unit is coming from a star, what is the limit of the resolution of the telescope whose objective diameter is 100 inch? So calculate lambda value 6 into 10 power minus 7 meter. Hope all of you are understanding. In competitive exams, you have to save the time. Directly convert 6000 into 10 power minus 10 meter means 6 into 10 power minus 7 meter. Diameter value will be 100 inch. 1 inch means 2.54 centimeters. So this value will be, convert this into meters better. So into 100 into 2.54 into 10 power minus 2 meter. So this value 2.54 meters. Okay. Then what is the limit of resolution? Delta theta is equal to how much? Telescope. So for telescope, delta theta is equal to 1.22 lambda by A. So delta theta is equal to 1.22. 6 into 10 power minus 7 by 2.54. After calculating this, we will get it as 2.9 into 10 power minus 7 radians we will get. So this is the answer for it. See the next question. Width of the slit 0.012 into 10 power minus 3 meter. But 12 into 10 power minus 6 meter. Angular position of the first bright line, they gave it as 5.2 degrees. Okay, what is the wavelength of the light incidented? Okay, so for bright line, A sin theta is equal to 2n plus 1 into lambda by 2. So here, what we had to find lambda, remaining all values we know. A value 12 into 10 power minus 6 sine 5.2 degrees. plus 1 first bright line, lambda by 2. Now they gave here sine 5.2 value 0.0906. You substitute. So 12 into 10 power minus 6, 0.0906 into 2 by 3. 3/4 will cancel, multiply all of that. Finally, we'll get lambda value is 7248 angstrom unit. We will get, just calculate, you will get the answer. So 59, it will be fourth option. Next, 61, you see, two stars distant 2 light years are just resolved by a microscope. Here one star is there. Here one star is there. From this telescope, these two stars are just resolved. Like that it is there. Okay. Here one star is there. Here another star is there. Here telescope is there. Okay. The diameter of the lens of the telescope is 0.25 meter. What is the minimum distance between the stars? These stars distance, they gave it as 2 light years. Okay. Then how to do delta theta? This distance is how much they are asking. So delta theta is equal to 1.22 lambda by b. Delta theta value will be, this is delta theta, this is small d by capital D. 1.2, I mean, you write here, lambda by a. So small d is equal to 1.22 lambda d by a. 1.22 lambda value 5 into 10 power minus 7. Here they give 5000 angstrom unit means 5 into 10 power minus 7. D value 2 light years. 2 light years distance is there. So 2 into any clue given for light year. So distance traveled by the light in, you write here or otherwise. 1 light year value will be equal to 9.4 into 10 power 15 meters. Distance traveled by the light in 1 year. 1 year is 365 days, or otherwise 365 days. 1 day will have 86,400 into c velocity of light 3 into 10 power 8. If you multiply this, you will get this value divided by a value. They gave it as 0.25. If you calculate this value, finally you will get it as S is equal to V into T. This is 3 into 10 power 8. Time value 365 into 86,400. That's why we wrote here. So finally, if we calculate this value, how much we will get here is, so this value will be equal to 4.58 into 10 power 10 meter we will get. Okay. So write it clearly. How, why this is came with S is equal to velocity into time. 3 into 10 power 8, 365 days. One day will have 86,400 seconds. That's why we substituted what I wrote here, I substituted here. So this is not 4.88, 4.58. This is I calculated 4.58 into 10 power 10 meters. Next, the penetration of light into the region of geometrical shadow is called diffraction. Next, what is the question? See, a diffraction pattern is obtained using a beam of red light. If the red light is replaced by blue light, what is the width of the diffraction pattern? Beta is equal to lambda d by A. So they replace red light with blue light. So lambda red greater than lambda blue. Red light is having maximum wavelength. So wavelength decreases. So beta R will be greater than beta B. So that fringe width will decrease. Therefore, fringe width will decreases. So this is the answer for it. Diffraction bands become narrower and crowded together. Next question. A screen is placed at a 50 centimeter from a single slit, which is illuminated with 6,000 angstrom unit light. Distance between the first and third minima in the diffraction pattern is 3 mm. What is the width of the slit? Minimum distance, what is the formula? Ym is equal to n lambda d by A. Okay. So according to this, third minimum will be, so y3 minus y1. 3 lambda d by A minus lambda d by A. This is 2 lambda d by E. Okay. This distance they gave it as 3 mm. 3 into 10 power minus 3. 2 into lambda value 6 into 10 power minus 7. 50 centimeter means 0.5 meter. D, this is D. This is lambda. This value will be shift distance between that. By A value, we had to calculate. If we calculate 6 into 0.5 means 3 only. So 3 will cancel. A is equal to 2 into 10 power minus 4. 0.2 into 10 power minus 3 meter. So A is equal to 0.2 mm. So this is the answer. Next. In a single slit diffraction experiment, first minimum for lambda 1 is equal to 600 nanometer coincides with the first maximum for wavelength lambda 2. First minimum means 1 into lambda 1. Coincides with the first maximum means 2 into 1 plus 2n plus 1 into lambda 2 by 2. This is 600. This is 3 by 2 into lambda 2. 400. I'm see here they gave a printing mistake. See here it will be 660, not 600. So this is 660. So here we will get 440. This is the answer for it. 69, what they are asking, see. Parallel beam of monochromatic light of wavelength 450 nanometer. Lambda is equal to 450 into 10 power minus 9 meter. Slit width is 0.2 into 10 power minus 3 meter. 2 into 10 power minus 4 meter. What is the angular divergence they are asking to calculate? Calculate the angular divergence they are asking. So sine theta is equal to sine theta approximately equal to theta n lambda by small e. A sine theta is equal to n lambda, basic formula. So here this is 1 lambda value 450 into 10 power minus 9, 2 into 10 power minus 4. If we calculate, this is 2.25 into 10 power minus 3 radian. It is diverging like this. This value we calculated. This also we had to add. So angular divergence is equal to 2 theta. 2.25 into 10 power minus 3, 4.5 into 10 power minus 3 radian. 4.5 into 10 power minus 3 radian. Next, two Polaroids are oriented with their transmission axis making an angle 30 degrees with each other. Here one Polaroid is there. This is one Polaroid. This is its transmission axis. Here one more Polaroid is like this. It is making 30 degrees. Final emitted light will have how much? If I naught is emitted, here it will be I naught by 2. Here how much means I is equal to I naught cos square theta. I naught by 2 because this is I naught by 2 incidented. I naught incidented here, it will be half I naught by 2. On this I naught by 2 is incidented how much? What is Malus law? I is equal to I naught cos square theta. This is Malus law. Here how much incidented on this mirror? I naught by 2. So extinguishing light will have I naught by 2 cos square theta. So I naught by 2 cos square 30. This will be 3 by 4. So 3 I naught by 8. So if we calculate I by I naught, 3 by 8. I by I naught into 100. 3 by 8 into 100. Okay. 12.5 will come. 8, 12.5 are 100. So this is 37.5%. Okay. So this is the answer for it. These problems on the polarization. If you are only preparing for CET, Just neglect this problem. So here from 70 onwards, you neglect. Unpolarized light falls on two polarizing sheets placed one on top of the other. What must be the angle between the characteristic directions of the sheets if the intensity of the transmitted light is 1/3 of the intensity of the incident wave? Here one polarizer. This is its axis. This is another one. Find this angle. Here I naught incidented, I naught by 2 will come. I is equal to I naught by 2 cos square theta. This I value is I naught by 3 they give. 1/3, see here, 1/3 of intensity. Cos square theta. So cos square theta is equal to 2 by 3. Cos theta is equal to root 3 by 3. 2 by 3. Theta is equal to cos inverse root of 2 by 3. So this is the answer for it. Next. Unpolarized light is incident on a plate of refractive index mu, and the reflected light is found to be completely polarized. So Brewster's law, mu is equal to tan I. Root 3 is equal to tan I. So tan 60 is equal to tan I. I value will be 60 degrees. Angle of refraction also they are asking me. Mu is equal to sine I by sine R. So here what will happen? Root 3 is equal to sine 60 by sine R. So sine 60 value root 3 by 2. To sine R. This root 3 will get cancelled. So sine R is equal to 1 by 2. Sine 30 degrees. R is equal to 30 degrees. Therefore, R is equal to 30. I is equal to 60 will be the answers. 60, 30. These are the answers. Next, in the propagation of electromagnetic waves, angle between the direction of propagation and the plane of polarization, that will be 90 degrees. Next, the angle of incidence at which reflected light is completely polarized means mu is equal to tan I is equal to tan inverse mu. Here mu place they gave n, so tan inverse n, standard simple bits. Next, angle of polarization is 60 degrees. What is the critical angle? Mu is equal to tan I. This is equal to 1 by sine c. Here tan 60 is equal to 1 by sine c. Tan 60 is root 3, na? Root 3 is equal to 1 by sine c. So sine c is equal to 1 by root 3. Therefore, c is equal to sine inverse 1 by root 3. Next, 83, what is that? C. Optically active solution, what it will do? Rotates the plane of polarization of polarized light. Theory bit. In a single slit diffraction of light of wavelength lambda, by a slit of width E, the size of the central maximum on the screen at a distance B, how much they are asking. Generally, we will use width of the central maximum as 2b lambda by E. A. This is the formula for 2 lambda d, or instead of capital D, small b, and small d, small a, we will use. This is the width of the central maximum. Exact formula will be plus a will also come. So among the given, exact formula will be 2b lambda by E plus E will be the formula. Okay. So next 87, you see what they are asking. Ratio of the intensity at the center of a bright fringe to the point at 1/4 of the two fringes from the distance will be how much they are asking.